Hi students and my dear learners. Again, welcome to the 32nd video of Engineering Thermodynamics. And in the last three videos, we have been discussing about vapor power cycle and the components of steam power plant, right? So here in the last video I explained you how a thermal power plant is working and how the work output was extracted by the utilization or supply of steam which is produced by the boiler. Okay, so in this video also let me explain a little bit detailed with the concentration on the important components where we are going to start our analysis. Okay, so you have seen the full view and the full layout of the steam power plant in the last video, right? So this is the simple version or the steam power cycle analysis purpose. What are all the important devices which are applicable to produce the power is going to discuss now. Okay, so here, as I told, always I am starting with boiler because this is the initial device which converts the water into steam, where I told already boiler producing steam in which the water is undergoing the phase change from water to steam. Okay, so here latent heat of vaporization. What is latent heat of vaporization? Is the that much amount of heat has to be given to boiler, so that only water at 100 degrees Celsius, that is depending upon the pressure, would be converted to steam. From where it is taking the heat? By burning of the combustion of coal and the air. Okay, air and the fuel. Okay, what is the outlet from the boiler? Is combusted products. Okay, flue gas, waste gases will come out and it will be removed through the stack, okay, or chimney. Okay, so here boiler means heat supply takes place and phase change occurs from water to steam. After the high pressure, high temperature steam, here it is mentioned, yeah, high pressure, high temperature steam produced by the boiler is supplied to the inlet of the turbine. Turbine has nozzles and blades as an integral part, in which this high pressure, high temperature steam is giving its energy to the blades and make the blades to move, to rotate at the faster manner. So just think, in your home you just boil the water in a vessel, and don't switch off the stove till it gets boiled and it gets all the bubbles and all. Now if you show a small lid or any weightless, that is a less weight lid on that boiling water or evaporated water coming out of the vessel, then that lid will start to shake, or even that water will force or make that lid to fall from the vessel, from the top of the vessel. That is called work. Okay, that is called work. When you are boiling the milk, it is coming up. Okay, so always whatever the molecules in the world, when it is absorbing the heat, it will starts to move. So here this high temperature, high pressure steam is also moving something to which the moving is given to the shaft. Okay, so this energy of the steam is converted to rotation of the shaft. Okay, so you be clear with this one. Here only heat is converted to useful work. Okay, so now it has given all the energies to the shaft, right? So now when it leaves the turbine, the steam leaves the turbine, it would be at low pressure, low temperature steam. What is the state of the steam? Is low pressure, low temperature steam coming out of the turbine, entering into the condenser. Okay, condenser is the reverse device for boiler. I told in the last video also. So in condenser what happens? Again, low temperature, low pressure steam is giving out its heat to the cooling water which is circulated inside the condenser, and thus steam, low pressure low temperature steam is converted to low pressure low temperature water. Okay, high pressure high temperature steam converted to low pressure low temperature steam by the turbine, and low pressure low temperature steam would be converted to low pressure low temperature water in the condenser. Here water to steam, here high energy steam to low energy steam, here low energy steam to low energy water. Okay, and thus here heating, here cooling, here that is expansion. So one more device which is needed to give the pumping process or the pressurizing process, like compressor, right? So here we are using the pump. Okay, feed water pump. That is low pressure low temperature water coming out of the condenser is supplied. It's supplied again to the boiler with the aid of pressure, the pump which is increasing the pressure, increasing the energy of the water, and thus the water is it is making the flow towards the boiler. Since this pump is giving the energy, that's what the water could be able to go towards the boiler. Always I told, even you are having the working fluids or any substances, if you take, if we are making the movement or flow from one place to another place, then only it could be transformed from one place to another place. That purpose is fulfilled by compressor, pump and other sort of power absorbing equipment. Turbine is power producing equipment where expansion takes place, and pump is a device in which compression or pumping or pressurizing takes place. Okay, so heating, cooling, energy extraction, here supply of energy, here work producing machine. This turbine is work producing device, here it is work absorbing device. Of course it has to do, it is supposed to do its work, that it has to make the water to flow towards the boiler. So we have to, it is supposed to supply the work for the pump. That work or electrical energy to run this pump is supplied by the energy or the electrical energy produced by the that is mechanical work which we are receiving from the turbine. Okay, you be clear my words. Boiler is for phase change, and condenser is also for phase change. Here heating, here cooling occurs. Okay, and turbine, high pressure high temperature steam is converted to low pressure low temperature steam, and the energy of the steam is utilized for work. And here high pressure, low temperature water is converted to low pressure, the high pressure, high temperature water by the input. Here working substance in turbine, working substance energy is decreasing. Here in pump, the energy of the working substance is increased because of the energy, external energy supplied to it. Here it is supplying the energy or work to us. Okay, direct opposite, heating, cooling, expansion, compression. Here substance energy removed, here substance energy supplied. Okay, removed means that has to go as a useful work of shaft work. Here supplying means we have to give the electrical energy so that the energized water is could able to flow, okay, towards the boiler. Okay, if you are very clear with this one, the whole second half of vapor power cycle would be very easy to you to follow and understand and solve the problem. Okay, so boiler, turbine, condenser, the water pump, these are all the four very important or a vital part of a steam power plant. And other many accessories and auxiliary devices are being used in steam power plant, but for power production related analysis, we are going to study about only these four devices in detail in the forthcoming all the videos, right? So here also it is explained, always this numbering you just try to know. Inlet of the turbine is taken as labeled as 1 and outlet is of course 2, and 2 is not only the turbine outcome but also the inlet of condenser, and the state 3 refers the condenser outlet. Here heat supplied, here heat rejected, and 3 states that inlet of pump, 4 is pump outlet, and as well as inlet to the turbine. Okay, so here working is same: heating, cooling, heat supplied, heat removed. Here phase change occurs from water to steam, here phase change occurs from steam to water because of heat removal. Okay, so here turbine working substance energy is released or taken in the form of shaft work. So expansion takes place here. Compression or pressurizing or energizing is taking place to make the flow from one place to another place, and that work what we are giving is utilized for making the movement, making the flow work. Okay. So now in the next video, let me go in detail about Rankine cycle. Before that, I want to give some introduction about what is the importance of Rankine cycle. You know very well that Carnot cycle is one of the hypothetical and ideal cycle for all sort of working substances, which gives the maximum efficiency, and it consists of two reversible constant temperature or isothermal processes of heating and cooling, and two reversible adiabatic processes of expansion and compression takes place in the Carnot cycle, which we can taken as a standard cycle, and for comparing with the other cycles, we can take the Carnot cycle as a basic and standard cycle, right? Because only Carnot cycle can yield a maximum output or maximum thermal efficiency which other cycles could not able to even reach or touch the Carnot cycle efficiency. Why no? Why we are taken that much a high level of place to the Carnot cycle is it could not be implicable. It is very tough to execute the Carnot cycle. It is an ideal one. Okay, if you become okay, now let me continue in the next video. Thank you.